Thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel within 3 to 4 days. I will share the link to our YouTube channel in the chat section soon. But before we start today's session, please feel free to do event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. I will share the event check-in link with the event ID in the Q&A section shortly. Also, we have launched our Reactor group on LinkedIn. Please feel free to join the group to get the latest update on session happening on Reactor. Quick word on a code of conduct. We display this at all Microsoft Reactor events that we run, and it's just a reminder to be aware of others. Key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. I would now like to welcome Jayesh and Vivek, our speaker for today's session. Jayesh loves exploring new technologies and putting them to work to solve real-world problems. He adapts very quickly to emerging frameworks, all languages, and plans his day to maintain balance between sports and coding. Jayesh enjoys speaking in public and interacting with people with different experiences other than his own. Our next speaker, Vivek, is a tech enthusiast and an open source contributor with around 15 years of experience in the software industry. He works at Microsoft as a senior cloud advocate. But for now, I will hand over to both of you to begin the session.
Yeah, thanks, Rashmita. And
Thank
yeah, I just want to welcome Jayesh again back to Azure Happy Hour. This is the second Azure Happy Hour in case if some of you missed the conversation we both were having before starting this session. And welcome, Jayesh, to the session again.
thank you,
And
Vivek.
and Jayesh is amazing. I just want to spend 2 minutes on my experience with Jayesh. In fact, we both met in a conference where he was also a speaker. I was also a speaker. And then I was just checking his profile, and I saw like, hey, he's a student, and he was talking on some, technologies on Kubernetes and other things. And that 2 years back, it's like talking on to Kubernetes 2 years back is something really different, right? So specifically coming from a student was very interesting for me, and that's when I invited him for the first Azure Happy Hour almost a year back. And today is again we are having a specific discussion on microservices and other things. So I again want to welcome you, and I just want to start the discussion. Obviously, you have a couple of slides, a couple of things which you want to show. So I just want to start the discussion with for our audience, for people who have just joined in as freshers, or probably would have not worked on microservices or trying to figure out what is a microservice. So we could start with that. What is a microservice, and why? There are a lot of definitions out there, and a lot of confusion between people. People think this is a microservice. This is, it has to
Correct.
be a different things. Um,
Mhm.
and it would be great if you give from your perspective. If you can share what is microservices, and then you can obviously start with your flow, the way you have designed this discussion as well. And obviously, I'll be bugging you with questions. So,
Definitely.
so in between, I'll be stopping you and bugging you with questions. And audience as well, feel free to share your questions in the chat. We will ask questions to Jayesh, and if at all something which we want to answer, we will definitely pick that up right then. Otherwise, we can
Mhm.
keep that question for the end, and we can have a discussion there. So go ahead, Jayesh.
Perfect.
All yours.
Yeah. So to answer that question, microservices is different from what most people usually follow, which is a monolith architecture. So in a monolith architecture, you may be familiar with that since it involves building your entire application in just say one application together. So you're running your code in your local system as all different files are together, grouped in some directory, and then you are running the application. You're accessing a common database. So all of that comes under what we call as a monolith, because here all of those services are talking to each other on the same network, right? So you're not actually making calls to other services. You are just referencing them all together. So that is the idea behind monolith. With microservices, what we try to do is we try to split the application up into different services. For example, if you have really huge application, right? So microservice usually comes into picture when you have a really huge application, not small applications. So for example, if you have very high number of services together in your application, you're doing lots of works. For example, say imagine if you have a say Uber Eats kind of a service. So you have orders, you have customers, you have multiple different services, all of which are huge on their own and they interact with each other. So all of that is really complex in itself, right? So in those cases, what we do is we try to break those things up logically into different parts, right? So we'll talk about the patterns there in a short while. So basically what we do is we try to split all of these in different concerns, right? So each of the microservices will be dealing with only one specific concern there. So you try to create manageable sections of codes, each which handle different functions which are independent of each other, and then you deploy them independently. And why do you deploy them independently? That is because you want them to be able to scale individually, or you want to diagnose each of these problems individually. For example, if one of the applications, if one of the functions of the application is really high consuming, like for example, it handles a lot of traffic, a lot more traffic than the other parts of your application. So you want that to scale individually as compared to the other parts. So that is one of the things, right? So these are different things which you want, which are the benefits of trying to split up your monolith in different parts, right? Having each of the parts of your application access different kinds of databases. So there are multiple things. Now, to encapsulate all of that together, we'll be looking at design patterns from microservices. So first, let me just start presenting my screen, and then we'll get back to this question. And just a sec. Yeah. Let me know if my screen is visible.
Yes.
Okay.
Yep.
Yeah. So introduction is pretty much done. So thank you, Vivek, for that. So I'm just a final year student at IIT Bhubaneswar. I'm also a Microsoft Student Ambassador and really proud of that. And we have had a lot of discussion with the community, and there's lots of important things. So if you're a student, do check this out. And it's really nice opportunity, really nice community there. I'm also been a community bridge mentee for CNCF. I worked on Code DNS in my summer last year. And I'm a YouTuber. I write blogs, and I also love speaking in public. So I'm also a tech speaker. And I love open source. That's all. So let's quickly jump back in. So in today's session, as we already discussed, we'll be talking about microservice architecture, first of all. Then we're looking at what the typical implementation is. Like, how do you typically build microservice applications, right? So that is what we'll look at. After that, we'll look at what is serverless. Now, you may have heard of what serverless is. We'll look at just things in which what are the basic principles? How do you identify a serverless option? How is it different from traditional approaches? All of that will be covered in this section. Next is the serverless offerings in Azure, where we see what different offerings there are. So there are multiple services. You may get confused about which one to use at what point. Is it truly serverless or not? Is it PaaS instead, like platform as a service? So all of that will be covered in this section. And lastly, we'll see how we transition to serverless. So we'll take our entire application and we'll push it to serverless technology. And all of this will have corresponding demos. So we'll be looking at all of these things on the portal, Azure portal, instead of the slides. So yeah, coming to the question of microservices, as I told, the basic principle which guides how you transition your monolith application to a microservice application is a single responsibility principle, right? So what is this principle? So it basically tells you that when you're trying to split your monolith into different parts, you should look at things that is my individual microservice only handling just one part of my application, right? So it should only have one responsibility. You should not handle multiple things together. So if you have a microservice which is handling multiple things, you should break it up into smaller microservices, right? That is the fundamental way in which you split your application into different services. So that is the single responsibility principle. So you just have loosely coupled different multiple services all working together, right? The second is the aggregator pattern. So these are just different patterns which I'm trying to give you an intuitive understanding of, so that you will have a better idea. You can form a better picture of microservices, right? So let's just imagine you have three different services. Let's say A, B, and C. All right. So all of these services are there. Now, in case of a monolith application, you may imagine that when you made some request to your monolith application, that request internally would have been serviced by multiple services, correct? For example, if I wanted to find out if my customer can withdraw more money, in that case, I would need data from the customer service. I would need data from maybe say inventory service, something like that. So any request which comes into the monolith application might have been serviced by different parts of the application. It doesn't necessarily have to be serviced from one single service, right? So when you have now split the monolith into different services, how are such requests handled, right? For example, if I send a request to some point in my application, how will it coordinate with all other services and bring all the data I need in one single request, right? So you need some kind of another service which acts as a aggregator. So I'll just make call to this particular service, and then this service in itself will know the entire architecture. So the customer doesn't need to know what the architecture is, how many microservices there are, what are the purposes of different microservices. It just needs to know that there is one aggregator microservice here. This in itself will have the purpose of calling different services, coordinating between these tools, and then taking output of all the microservices and then packaging into one solution and sending it back to the customer, right? So this is the part which links the monolith functionality with the microservice functionality. So we have replaced the entire implementation, but we have kept the flow in the similar fashion, right? So the flow is still the same. You're still calling a particular endpoint. Now this endpoint, how does it fetch all of that information? Is that is what is changing, right? So there are two ways of implementing this aggregator pattern. So the first one is implementing another service, right? So if you have three different services, say order, customer, and some other service, you can implement a fourth service here. And the only purpose of this service will be to act as a kind of a controller. So if you're familiar with MVC architecture or something like that, model view controller, you will understand what a controller is. So controller basically has the function of forwarding your requests which come in from the client to different specific parts. It knows what requests need to be forwarded to what different services and how many services to call, right? So that is the purpose of an aggregator. So you can either implement a microservice which handles all of this communication, or you can implement an API gateway. Right? We're looking in detail about what an API gateway is later on, but it's similar to that. It just takes all the common concerns for different microservices and not packages up into this one particular service. So it's a single point of entry into your application. That is one of the primary functions of API gateways. There are more other functions as well, but we'll not cover all of that here. And this is the idea. So aggregator pattern can be covered in two different ways, a composite microservice and an API gateway, correct? Now let's just look at the API gateway pattern in specific. So this API gateway pattern, what this does is, let's just first look at this diagram here, which I built. So this is the API gateway. And as I just made you imagine, there are three services inside, which are service A, service B, and service C. And now since these are independent, I have thought of them as being implemented in different languages, just to demonstrate that all of this is language agnostic. So you can see service A is in Python, service B is in Node.js, service C is in Go. So these are all different services inside of your cluster or whatever where you're deploying the microservices. And there's an API gateway. So these clients, they don't have any information about how your application is structured, how many microservices there are, what languages they're using, what tech stack they're using. The only point of entry for them is this API gateway, right? So you define this API gateway. Now, what this API gateway does, there are a lot of responsibilities for this API gateway. The first thing would be to forward your request from the client directly to whatever microservice there are internally. Now, even if you change, say, the architecture of your entire solution, you only have to change some logic in API gateway, the routing in API gateway, right? The second thing which the API gateway does is, say, for example, if you want authentication to be built into your architecture. For example, if I have independent services here, all of them would have to have some kind of a layer of authentication, correct? If I didn't have an API gateway, so any client who's making request to service A would have to log in to the service A. So I will have to add some extra logic here to service A to make sure we authenticate the users. And similar is the case for all different services. So instead of repeating that implementation again and again, what we do is we take this common implementation and outsource it to some kind of entity, which is the API gateway. So API gateway also handles all kinds of common concerns. It can be also handle rate limiting. For example, if you want a certain client to only access only make these many requests per second, all of that is handled well within this API gateway. Right, so that is what the API gateway does. We'll look at the actual API gateway in the portal later on, and you'll get an idea of how this is. So this is a very common pattern. A lot of microservice architectures is built on this particular pattern. So you have multiple services and you have one kind of an aggregator pattern. All right, that is it. The other thing you'll notice in this diagram is I have built these cylindrical disks here, right? This is what I represent a database as. So for that, we'll look at the next pattern, which is database per service. So far we haven't talked about any databases. We just talked about how to structure your different services, how to first of all break up your monolith into smaller parts by using single responsibility principle, then how to replicate the flow of a monolith in case of a microservice pattern using an aggregator pattern. And then we looked at this API gateway pattern where we put all of that together, right? But an important missing concept is databases. Right? So in a monolith, you make the entire application access some common database, and you can ensure, say, consistency on all of that using ACID transactions. So it's just that there's one database there, and all of those services accessing this particular database, right? So that is really convenient in that scenario. Now, how do you handle databases in case of, say, microservices? So how many databases do you build? Do you build separate databases or do you not? Right? So that is addressed by this particular service, pattern. So usually this pattern tells us that each service, each microservice will have its own database. So you don't use a shared database, right? So you don't use a shared database. You have different databases for every service. Now, what are the benefits of such an arrangement? So the first benefit you can think of is, let's just say I have, say, this order service, right? This order service has an order table here, and there's a customer service, the customer table. Now, all requests which I want to make to this order table, say for example, if I have to modify any particular row in the order table, right? So that request will have to come in through this particular order service API, right? So any implementation which I have, so for example, say I want to limit who can modify my table, or I want to limit how the table is modified. So all of that code can be put inside this order service class, right? And then I'll expose that API to the external world. So I'll expose some API, and all the different services, say for example, if there's an X service or Y service, all of those services will first communicate through this API and not directly modify my table, right? So I can control the access to this table. That is one of the important steps in which this kind of pattern helps. And moreover, say for example, in the future, if I want to modify this implementation, say for example, earlier I used to allow the rows to be modified. Now I don't want that to happen. So if I didn't have a common, say if I didn't have this implementation here, in that case, I would have to modify each of the caller codes, right? For example, if 5 services are calling this database, then I have to make this policy implemented in all different 5 services, right? But now what I have to do is I just have to modify the code inside this order service, because this is the API which all the other services are using. So that is really convenient in that scenario. So this is one of the benefits of having one database per service pattern. The other thing is, yeah, go ahead.
Just 1 second. So there are a couple of questions here, right? So
Mm-hmm.
so if you go at the top, right? So most importantly, to understand about microservices for the audience here, um, it's more important to have a business capability. Okay, so you should have a business justification of breaking the services into a microservice, and
Mm-hmm.
how you want to use it. So that is what the coupling means there at the top, where you were talking about at the top. And there is a question in the from the audience, like what are the patterns and best practices for managing services to service communication? We will come to
Mm-hmm.
that when we talk about the architecture and the code and how each two of the services talk to each other. There are
Mm-hmm.
various strategies. There are CQRS
Correct.
strategies. There is
Correct.
event-driven strategies,
Mm-hmm.
you can use and other things. So we'll come to that uh, discussion when we are at that pattern. And there is one
Mm-hmm.
question from the audience is that you know different databases for each service, different database is still it's still a debate. People
Yeah.
are debating whether it has to be like that as per design and other things. So that is the reason I posted the Martin Floer's characteristics of microservices. He has clearly defined what needs to be a microservice and why you need to have a decentralized database, a database which means data management system, decentralized governance systems, which is
Mm-hmm.
also which is also designed for failures and other things. So these are a couple of characteristics of a microservice. When you call something a microservice, there are a couple of characteristics, and it is well defined by Martin Floer. That's the link which I have shared as well, so that you can go back and read through that. Yes, by design, you would say I would say yes, by design we need to have it as a different tables. It will really help you to make it decentralized data management system, right? So there is a no failure
Correct. Correct.
which happens there. So that is the reason. And there is one more question. What is the relationship between the triple D and microservice? What is that triple D? I don't know.
Triple D is, I'm not sure what that is.
I'm also not sure. So if you could, share what the triple D is, that will be really helpful. Perfect. So
Okay.
let's go back and let's go back to your database as a service, and we'll come back to questions later again, so that you can
Sure.
continue. Yeah.
Yeah. Just to address the first question in a bit, I think the question arises because I saw the service mesh here. So that is one of the ways in which this different services can communicate. So that is, we're not covering service mesh in this particular talk, but you can check it out. Like Service Fabric is also one of the products in Azure. And you can also use open source service meshes like Envoy, Linkerd. So feel free to check those technologies out. But in this particular talk, we'll be talking of, say, Dapper, which really makes this communication very, very smooth. So we'll see how this communication can happen really fast, and you don't have to configure a lot of things on your end as well. So that is something which I would encourage you to check out as well. So the previous talk we had was on Dapper, which is a really important way in which you can communicate with different services. It encodes all the best practices together in one package, so you don't have to implement all those things yourself. So you feel free to check out Dapper and service meshes. So that is one of the ways, but we'll see them in action later on maybe. That is the idea. Now let's just get back to the database for service thing. So as Vivek said, it's still a debate. It's not the single way of doing things. If you feel you have to have a shared database, but in that case, you may think that you may not need microservices at all. So if you're feeling that the entire thing should be done with a shared database, maybe you could go ahead and do with a monolith as well. It's not wrong to build a monolith in that scenario, right? So that is the idea. I'm just discussing a very common pattern here, which is the database for service, and I discuss how this helps you in many different ways. So you can have different kinds of databases for different services. Say, for example, if somebody needs a NoSQL database for one service, or maybe some kind of fast access database from some other service. So all of those can be implemented by using these principles, right? So that is the idea behind it, right? So now one question that comes to mind when you look at this kind of database per service things is, how do you ensure consistency? Right. So for example, if you had just single database, you could do ACID transactions. So that guarantees that the entire database will be consistent after and before a transaction. But in case of multiple different databases where all of these are maybe deployed some on different servers under different providers and maybe using different technology, how do you ensure that all of this communication will be consistent, right? So that is a very important question here. So for that, I would recommend Saga's pattern. So it is a pattern which you won't be covering here because it's not part of the discussion, but I just wanted to highlight this point as well. So you do feel free to check out the Saga's pattern. It's really old, maybe in 1980 something, but it is really important. So it just defines that every transaction will have a kind of a compensation. So for example, if your transaction fell through, for example, if you made $100 transaction and it did not go through, then there will be another transaction which is of -100, and it will cancel those things out. So that is how it tries to make the database consistent. So do check that out as well. That is really interesting. Okay, so we are done with this. So we have so far understood that why microservices are important. How are they different from monolith? What are some of the very common patterns in which you can build your microservices? And we looked at the API gateway specifically. And now we'll look at what is the traditional way of implementing all of that, right? So what is the traditional way in which you can create microservices? All right, so now let's just look at this part. So yeah, coming back to this diagram, we looked at API gateways and the application. There are two parts here in this diagram, right? We won't be talking about databases here, but we will cover that sometime later. So API gateways, for API gateways, what are the possible options that you have if you want to build your API gateway, correct? So you can either if you can either hire a virtual machine, so you just rent a virtual machine and deploy your API gateway software on it. So you can either use open source software, or you can maybe develop something of your own if that is the case. So that is the traditional way of implementing it. Either do it on AKS cluster, so you can run it as a service inside of AKS. I'll be demonstrating that. I have a Kong gateway running on an AKS cluster. So that is one of the ways in which you can do it, because in that scenario, you are controlling what resources you want to give to your API gateway, how will it scale, and all of its properties are directly under your control, right? So that is a typical way of implementing an API gateway. And as I said, some third-party project can also be used to serve as the gateway, or you can build your own in that case. But it will be running on some VM which you define, right? So either you specify what resources you have, you specify whatever policies you want to implement there. That is the typical way of implementation of an API gateway. Coming to apps, if you want to deploy some apps running on, say, you have to think of where to run your applications, right? So again, you have the common way of doing it. You can rent a virtual machine, install whatever software you want on it, and then run your applications there, right? Also you can run on AKS, so you can maybe containerize your application, then create an AKS cluster, the Kubernetes cluster, and then run your pods or containers in your Kubernetes cluster. That is also one of the ways of doing it, right? Or you can have an app service. Now, app service is not entirely what you call a traditional way. It is somewhat of a platform as a service thing. We'll be talking about platform as a service versus serverless a bit later. So we can also use app service. App service also is pretty much the same thing. You have different kinds of plans in app service which determine how you will do it. So I'll just go over there really fast. So let's just recap quite quickly what we talked about. So traditional approach would be deploying on provisioned or self-managed instances, for example, on AKS or an app service, right? And for applications, pretty much the same thing. You run either on VMs or you run on AKS. Now, I'll go to app service. For app service, let me just go to the browser once again. Right, so this is the app service pricing. All right. So this is really important in understanding how app service behaves in two different ways. So is it serverless or is it not? Is it platform as a service or is it not? Right. So first of all, let me talk about how is PaaS different from PaaS different from serverless. Right. So platform as a service also hides. I have a diagram for that. Just a sec. So let me just go over the diagram once and then we'll come back to it. So if you look at this diagram here, you will see that PaaS and serverless are pretty much the same thing in the way they abstract details from the developers. So even for platform as a service, you don't have to know about how the implementation is being happen, what is the compute resource that is being used. So even with PaaS, all of that is still intact, right? So this is the common part. Developers only have to write your application code, and you don't need to manage any servers, right? So that is why sometimes we feel that serverless and PaaS are pretty much the same. But the fundamental difference between these two is, first thing is the pricing, right? So PaaS usually charges a flat fee. So that is what I'll show you in the app service pricing. So if you look at the pricing there, you'll understand it better, right? So PaaS usually charges a flat fee. So even if you're not using it, it's still going to cost you something. Whereas serverless is entirely based on usage, right? So I'll just show you that as well. So it just depends on how much calls you're making or maybe how much compute resource you're being consuming at a particular point of time, right? So the serverless is entirely usage based. This is one important difference between a PaaS service and a serverless. And for examples, you can see for PaaS is app service and for serverless it's function. Now serverless in itself is of two different parts. You may heard of backend as a service, function as a service. So all of these two things are a part of what you call serverless. So we usually are familiar with the function side of things, but there's also a backend as a service, right? So you can maybe think of Firebase as one of the popular backend as a service thing. Okay, so now let's just go back to the pricing here. So in app service, you can see I have two different options. In the free and shared part, what I do is we don't actually provision any dedicated VM here, right? We're not actually spinning up a VM. We are just using any unused VMs around the place. In the case of basic dedicated environment, what you see is you get a dedicated VM here, right? So this is more of a PaaS kind of thing where you're paying a fixed part for this particular thing, and then there's this free and shared part which does not have a dedicated VM part of it. So that is just a small detail I wanted to share about app service. Now let's just get back to the topics. We're not deviating much. So coming to the typical implementation, as you said, there are two different ways. We can either use an AKS cluster, or we can define say on our app services. So first of all, let's just go to the portal and see how it looks like. So I do have an AKS cluster running. Now, remember the architecture which we saw. I've been doing all of that here as well. So I already have those services running. I'll just make you watch that and see if it's the way we want it. So let's just see if I have a single node cluster running here. And now this is taking just a while. So while making a Kubernetes cluster, so you'll have to specify what kind of nodes you want, right? So I just wanted one node, and what is the class of node I want? Like how much how much CPU do I want? How much memory do I want? All of that I specify before creating a cluster, right? So if I do a kubectl describe, right? If I do a describe and node and this one, so you'll also see what the allocation is. Right? So if I do this describe node, this one, so in that case it'll show you all the details about. Let me just zoom in a bit.
So Jayesh, can you just go back to the architecture diagram? So the way you have set up this whole thing is you have three services, right?
Mm-hmm.
Service A, which is in Python, and service B,
Mm-hmm.
Node.js, service C is in Go, and it has
Correct.
its own databases. Which database you have for each of these? Is it different databases or the same database?
So for now, we're not talking about databases, but I'll also tell you how to do it. Like using Dapper, we can configure all kinds of databases. So we have a common interface, and then we
Hmm.
can plug in different kinds of database. We can use a MongoDB, we can use a Redis database. So all of that really is flexible. So it doesn't matter what kind of technology we're using, but all of that can be facilitated using Dapper. But if
So
you want, you can
all
also
all these services are there on the Kubernetes right now,
exactly.
and with the namespaces and all the things, and you have a separate deployment, and then there
Correct.
is a service mesh we are using to
Correct.
talk to
Facilitate communication between.
between of these services, and
Correct.
then all these things have been connected to an API
Yeah,
gateway,
gateway.
just to manage your incoming traffic and
Authentication.
your authentication
Correct.
and
Rate limiting, all kinds of different.
obviously the routing of the services. Okay,
Correct.
got it. So,
So
this
all
is
of this, yeah. So
yeah.
currently all of that is part of the EKS cluster. So we're not looking at anything above. So we just provisioned a VM. We just had a virtual machine scale set. We built a cluster on top of it, and we're going to deploy all of this architecture entirely on EKS, right? So I'm just showing this thing now. So I had a one node cluster, and I can show you the specification for that. So this is usually specified before we start building it. So there's a CPU here, there's a memory here. So all of that is specified, and that is part of this node here. Now it doesn't matter if I'm consuming all of that. So you can see I have 1900 CPU, right? 1900 millicore CPU available, and currently all of my application combined together only request 1784. So we're not consuming entirely, and we can also expand it later on, and we'll just keep on staying idle. So this is the idea behind it. Now let us look at what services we have running. So let's just see if I have say service. So I have two applications here, Hello World and Hello World 2. So these are two different applications. I did not deploy the third service. I thought of doing it here, but it's sufficient to understand. So I have these two services running. Let me just try to access the external IP. I made this as a load balancer specifically so that we can access the URLs and see. So it says hello world from service A. So I can verify that this particular service is working, right? Now, what we want is, let's just look at if we have a gateway running. So I already implemented a gateway using Kong. So you can do it in any way, as I told. We can either build our own API gateway or we can use a third party like Kong. And that is also deployed as a service here. So you can see there's a Kong proxy, and that is an external IP, this one. So ideally what we'll do is will not have any external IPs for all of our services. So all service A, service B, these will only have cluster IPs. They won't be exposed directly to the external environment as we saw on this architecture diagram. So they remain a part of your cluster, but they're only exposed through this Kong proxy, which is the API gateway which sits at the front end, right? So if I access this external IP, now where is the routes defined for this one? So I do have routes which is defined as an ingress. So ingress is a object in Kubernetes which we can use to map different paths to different services. So I do have ingresses for this one. Let me just open this one. There's an ingress called route one. It's a class Kong. So Kong is the ingress manager for this particular route. So here I have defined like what path to take so that it will forward to what particular service. So ingress controls all of that thing. So this is all part of the API gateway, nothing to worry about here. So let's just try to access the external IP here. So this will be the Kong API gateway IP. As you can see, it asks for a username and a password here. So this is the way you can organize all of that here. So I'll just put some password here and log in here. So yeah, hello world, there it is. So I have tried to put a layer of authentication on top of it, and all of this is running inside Kubernetes. So I've just provisioned a single virtual machine, and all of it is working as it expected. But the obvious problem here is that I'm not consuming all of my CPU. I'm not consuming all of my memory. So there's obviously I'm paying more for what is required, right? Because these two services won't consume all of that resources. All right. So that is the idea behind it. So this looks like a somewhat of a typically how people implement their microservices on Kubernetes. Right? There's an API gateway. There's microservices. Now let's get back to our one note here. So yeah, we looked at this diagram. So we covered, say, these three services. We covered the API gateway, and all of it is running in Kubernetes. All right. So let's just go. Yeah, and yeah, we also have to configure scaling on our own. For example, if one of our service was having a lot of traffic coming in, then those scaling we can set on our own. We can say that we have to auto scale, or we have to set how many maximum replicas, minimum replicas. So that all of that configuration has to be handled through the Kubernetes APIs. And plus, if you want to do traffic management, for example, if you have multiple different versions of a service, say Hello World A has 3 different instances running. So how do you manage traffic between that? For that, we need a load balancer to be defined here inside of Kubernetes. So that is something which you do directly through the Kubernetes API, right? So this is the typical implementation. Now, how do you make it really simple? Like how do you consume only that amount of CPU which you require? How do you really streamline the entire process? So that is where the serverless things comes in. So what is serverless? So let's just think about that for a second. So serverless computing would mostly, the basic idea behind serverless is to eliminate all kinds of server management. So you don't need to know what VM you're provisioning, right? So what is the VM which is running your application? Where is it being run? So I want the developer to only focus on the particular code which the developer wants, right? So we need to focus on the business logic and making sure that our application is performing the way we want it to. Where it is being run is now the headache of what cloud provider you're using, right? So the only purpose that you have is to package your application into some kind of a containers and then just run it on some platform. And what that platform is not to be your concern in that case. So with serverless applications, the cloud service provider will automatically provision, will scale, it will manage the infrastructure required to run your code, right? So you don't have to manage any of that on your own. So with Kubernetes, with AKS cluster, you manage that. You have the power to directly manipulate any of the properties of the cluster using the Kubernetes API, right? So you have the entire control in that case. But what we want is developers to just package the code into containers and be able to run it on managed systems somewhere, right? So this slide pretty much covers all of that together. So there's no infrastructure management. There's dynamic scalability, which scales automatically depending on what traffic your application is facing. Faster time to market because you don't have to manage all of these things on your own. You don't have to debug these problems. It was already done on best practices already. And this is obviously more efficient use of resources. So since we saw there was a lot of wastage there, but here we are only going to pay for what we're consuming and not more than that, right? So these are the very obvious benefits of transitioning to some kind of a serverless compute. All right, so this is the idea behind it. And we already talked about PaaS versus serverless before. So these are two really close terms, and it's important to differentiate between all of these things, right? So now let us look at what are the offerings. So enough of the theory part. Now let's just look at how you're going to actually implement serverless inside of Azure. Correct. So the first, there are multiple ways of doing it. Honestly, there's no single approach of building a kind of serverless architecture. You can try and build different things. So the first thing is serverless Kubernetes. So we looked at AKS, right? We looked at the node where there was a lot of consumption there. Say for example, if you consumed all of the resources on that particular node, now you would want to provision a new node entirely, correct? So instead of provisioning a new node, what this method does is it only provisions single containers. For example, if you need just 3 additional containers, you don't have to spin up an entire virtual machine to host those 3 containers. What this will do is it will using Azure container instances. I'll talk about Azure container instances in just a while. So using this technology, it will just spin the exact number of new nodes that you want. So in kind of a, you're extending the functionality of AKS, right? So there's a very important blog. There's more resources on this available. So you should check that out. But for now, let's check out what ACI is, Azure Container Instances, right? Because it's really important understanding how this thing works. So Azure ACI would be, just let me just go to the container services here. Where is it? Container instances. So Azure was the first public cloud to introduce container instances. So basically, it just makes container as the high-level block. Right? So you don't have to think of in terms of VM. You can think of in terms of container. So what you do is you just define. I already have a service A container running basically. So what happens is this. Let me show you how you create this container. What are the steps in doing that? So you specify like this is the amount of resource that this container want to consume, and this will run on its own. So it's basically you can think of as a standalone service running. So it doesn't have any kind of orchestration. It does not have any scaling on its own. It does not have any communication with other container services. But if you have a standalone process that needs to run, you can run it as a container instance, right? So this will be a self-contained instance which runs entirely, right? So this is how you build one. So you just specify what image you want and you specify what kind of resource your container might consume, and then it just becomes one unit, and you can deploy multiple units like that. So that is how I created was this service A unit, right? So this is just a container instance running here. It has that image of my service A, and this is how I monitor CPU and all of that thing. So this is just has only one container, and again you can add identity and all different kinds of monitoring and stuff on this top of that as well. So this is using this concept ACI along with AKS also allows you to build some kind of a serverless approach. But serverless is not just one thing. You can implement it in multiple different ways. So with this, you have some idea of what ACI is, and using ACI with AKS will help you achieve serverless Kubernetes. That is one of the things. The second way of achieving serverless on Azure is the serverless functions, which is the Azure Functions on a consumption plan. Now, again, yeah,
just hold on there. So the first point where you're talking about serverless containers, it is called as virtual kubelets. It is one of the CNCF projects as well. It's a virtual node. So basically, it is the integration between the Kubernetes and how you can integrate with containers instance. So it not necessarily with Azure Container Instance, you could have container running in any platform or anywhere, and you can use something called as virtual kubelets, which is an open source implementation. And within Azure, we call it as virtual nodes. When you create Kubernetes cluster, you can see there's a virtual node where you can just create that virtual node, That is the one of the implementation of the serverless, which Jayesh is talking about, where you can integrate both of these things to build a serverless kind of a architecture for yourself, right? So basically, you can keep scaling, and you have only two nodes, but at the back end you have container instance is attached to the virtual queue as part of the cluster, and it is basically the implementation of kubelet, which is nothing but a binary of your worker node of Kubernetes, right?
Correct.
So it's taking care. It is just reporting what's running, the pod it's running, and status of the pod and other things back to the your master node. So that's the implementation there. So just wanted to make sure that everybody is aware of the terminologies there. So go back to your list of things.
Yeah, sure. Yeah, virtual kubelet is really interesting. I looked at it as well. We Micro donated it to CNCF, and it's really vibrant open source project there. So yeah, coming back to function apps. So we were looking at what are the different options for building serverless applications. And the first one was using the AKS along with ACI. And then we can also build function apps. So you may be familiar with how function apps are. But here also you can have two different options when you're creating a function app. You can either create it on your what you call, say, a consumption plan. So what a consumption plan means is that how much calls you make, it you will charge only on that basis. Or you can also choose an existing app service plan. So if you have, say, kind of an app service running, say if you have a VM provision for an app service and it has some space left, so you can also use that particular space inside of this thing. So it depends on what kind of plan you use. So that is something which is also, you can check it out. So on a consumption plan, Azure Functions behave as a what you call on a usage-based pricing model. Or you can also make it use any of your existing app service plans as well. That is the idea behind it. And function app is usually event triggered. So for example, if you look at any of the function plans, you have, say, HTTP triggers or, say, queue triggers. So you can make this code run in case of some HTTP event, or in case of when a new element is added to a queue or removed from a queue. So it basically has just the code there. You don't have to specify again what environment it is running on. You can choose from multiple different languages, Java, Python, any language to think of. You can just write the code here in terms of functions. So if you look at the functions here, you can see I have two functions implemented. I can just create a new one. So it'll just give you an editor to edit all of that content here. So you don't have to worry about where this content is getting run, right? So you can just set from all different types of triggers here. So there's a lot of different triggers. So this is basically the idea behind it. So functions is mostly event driven code which runs on the cloud. All right. So this is the idea behind function apps. All right. So that is one of the ways in which you implement. Apart from that, you have the serverless application being run on app service, right? So we already talked about app service before. So as I told you, it provides shared compute resources on the free and shared plans where your apps run on unused VMs, right? Potentially alongside apps from other services as well. So this is the part where you can utilize app service as a kind of a serverless kind of way. It is not exactly, app service in itself is not a serverless solution. It's more of a PaaS solution. But on the free and shared part, it does behave in some of that ways in which. So serverless is not exactly, there's no strict boundary on what it is. You just see how your computers are being provisioned, and that way you can identify if it's a serverless or not. All right. And finally, we have this new container apps solution, which is really perfect for building different microservices. We'll look at why it is perfect and how it compares with the other services here. But this is also one of the ways in which you can build, say, serverless applications. So it is fully managed serverless container service. So let's just go back to the portal, and so that we understand better. So function app, as you know, it's only event driven, right? For example, if you want to have, say, at least one replica of your application running at all times, so in that scenario, function app won't be sufficient in that particular use case, right? So you need some kind of a way in which you can specify any amount of replica which is running, and which also scales depending on demand, right? So that solution will be part of the container apps. It's relatively still news in public preview. It hasn't touched general availability yet. So here I have these three different services: service A, service B, and one demo service, just like that. So let us first look at how you create a kind of a container app. What are the steps in which you create a container app? So that will give you more clarity on what this thing actually is, right? So you just specify the name of the container, and you specify a thing called the container environment. Now, what is a container environment? Environment doesn't have to be in the environment. You don't have to specify any kinds of limits for CPU and memory. Just create an environment so that all of your container apps can live inside this particular environment. It's kind of a pod. If you're familiar with Kubernetes, you may think of it as in terms of a pod, or in terms of a kind of logical boundary for all of your container apps. So if you have, say, in this architecture diagram which we had here, let's just look at this architecture diagram. So say in terms of this thing, so this boundary which you see, this can be one environment. So in this one environment, I'll have 3 different container apps running. Right, so all of these containers will write logs to the same environment, right? So if they'll have shared logs. You can make them share resources, share networks. So all of that can be done because they're part of one single environment. So that is all. So in terms of metrics and in terms of logs, you just create one environment name. You just specify what region it is, and you just go ahead and create one new container in terms of it. So just basically creating a new microservice here. So you can think of it as a new microservice in terms of this thing. Now, when you go to the next part, you specify what kind of application is this running. So you have to specify a kind of image here. So this is where you specify the name of the container, and then you specify what image that is. So I'm using docker.io, and we can specify my third service name here as well, right? So this is the part. You specify what kind of CPU memory you want for this particular container, and then you go ahead and you just create from there, right? So you don't have any more specification that you have to do it now. But remember, we also talked about how it scales independently, how it integrates with Dapper. So where is all of that happening? So let us first look at the service, say, portal first of all. So this is a container app. Now on the left side, you'll see there are multiple different options you have. So I have an option for ingress. Now ingress is a way in which you control traffic inside your application. So for now, I have enabled this ingress and made it external. So I do have an URL for this particular service. This is the URL for this service. So using this service, I can directly access this particular thing. So remember in the Kubernetes example, there itself also I had an external IP for the service, right, which exposes your application entirely to the public world. So in this case as well, this is a similar functionality which you can be handled using ingress. So you can either control it within your own network, or you can maybe make it public on some particular port. Right? This is the idea behind it. Now, this is really important. This is the revision management. So here, basically, all of the different benefits of container apps come in. Right? For example, if I just click on create new revision, here you'll be able to see the different benefits here. So the first thing is I'm not changing the container at all for now. Let's look at scale. So here you can see I have an option to scale my particular application in different ways. So you can also see there's an option to scale to 0. If I make it scale to 0, in that case, I achieve truly serverless achievement. For example, if I don't have any traffic at all, if my application is just sitting idle, in that case, it won't consume any resource. It will just scale down to 0. And whenever a new request comes in, a new container will be spun up. So this is how you achieve truly serverless kind of, this is a second. Yeah, sorry. I'm sorry about that. Yeah. So this is how you achieve a kind of a truly serverless way of operation by setting the minimum replica to 0. And this is how you control that. And here's the option to configure Dapper. Now, when you enable Dapper, now Dapper is something which we discussed already, but just to brief upon it, so Dapper allows different services to communicate with each other. Right? So if you enable Dapper in all of your different microservices, what it essentially does is it adds another container alongside your container, right? So you can think of it as a sidecar running alongside your container. So whatever container you had specified here, Dapper will just instill or inject another container on top of it, right? So whatever now, for example, if this service A has to communicate with service B, I don't need to know where service B is deployed. I'll just call the local host. I'll just call the Dapper instance which is running alongside my service, and this Dapper instance will have the job of communicating my request to the service B instance. So service B will also have a Dapper sidecar. The communication will only be between these Dapper sidecars, and my application won't need to know any details on where the different application deployed, how they are communicating, and all of that, right? So this can be extended to even databases. So you don't have to worry about where database is deployed, how it is deployed, what technology it is using. You can just, just communicate with this Dapper sidecar, and this sidecar will handle all of the different communications, either with the services or with the databases. That is the idea. So all of that integration is done very simply just by enabling Dapper here. So in a traditional Kubernetes environment, what you have to do is you have to install Dapper on your Kubernetes cluster. After you have installed, you have to add annotations to all of your Kubernetes manifest files. So annotation basically allow Dapper running on your cluster to identify what deployments to send, what deployments to inject your sidecars to. Right. So all of that configuration has to be done on your own. So installing Dapper, adding annotations, making sure the communication is working perfectly, all of that has to be done manually. Here, in the case of container apps, what you do is just enable this here, enter an app port, enter an app ID, and boom, you're done with it. So all handles on that. Yeah, go ahead.
So Jayesh, if you can just show the scale there,
Yeah.
you can also scale it by event.
Correct.
So from a Kata perspective as well, can I also add a rule? I'm thinking, yeah, scale through
Correct.
events. So there are different ways to scale as well, like either through traffic or through queue, or there is custom. I'm not
Yeah,
sure.
there's a lot of fields here in which you can specify secret
Yeah.
references. I haven't tried this out yet, but there's some way of doing it. Maybe it allows maybe third-party integration through this idea. Maybe
Yeah.
let's see if you have a secret reference. I'm not sure how this works, but there's something things to explore here. These two are simple. HTTP scaling, you just number of component requests you specify, and Azure queue is also very
Queue
simple. You
is, yeah,
specify queue it
number
is.
of queues in the field.
Yeah,
Yeah.
correct. So it scales directly on what rule you have, and also you can specify minimum maximum here. That is true entirely. Yeah. So this is all part of container apps. So it's all packaged together inside of container apps. So another cool thing which I want to show you is this. So I have say every time I push my code. So for example, I can enable continuous deployment here. So I
So
have my.
just one question there. So there is a one question which is very related to the thing which you are explaining now.
Mhm.
The question is about can I use Azure Container Apps instead of Azure Container Instance? I mean, these are the use cases, right? Right. Azure Container Apps, we saw there is a scale, there is event-driven scaling, there is a lot of other features which has even the integration with wrapper and other things. Azure Container Instance is where you're going to just have a standalone, like it's a container which you want to run there and you're running it there. You can have a number of instances run there as well, but it is just a number of instances increasing. But here you have the control. You have the control to do it, based on the HTTP request or based on the queue
Exactly.
filling up. So there is a difference between these two different services. So that is how you can do it, Amol. Okay. So go ahead. Now we'll take other questions as well, but I just want, don't want to, hinder
That's
the
okay.
flow. Yes.
Yeah,
Go ahead.
that is I like some kind of engagement because that is how we understand people are paying attention or maybe they're having some questions we'd like to answer. So definitely, yeah, containers are different from container apps because as Vivek told, there are multiple different integrations here. You can scale depending on different rules, but there, if you want to scale, you have to manually create different instances again. Right. So just you can think of container app as a container instance and then multiple integrations built on top of it. So it's an extension of. So you can think of it in that way. It's not exactly that, but think of it in those scenarios intuitively. All right. So coming back to it now, how do you we're talking about revisions right now. So how do you create a new revision? For example, if I wanted to modify some part of my code, right? So currently, as you say, this said this. Just a second. Why is it disturbing here? Just remove it. Sorry. Yeah. So when we access that particular service, it said hello world from service A, right? Now, if, for example, I wanted to change that message to some other message, right? In that scenario, whenever I create, for now I don't have the integration here. I have just the integration with the push. So let's see if I have Visual Studio Code running. I don't have it right now. But yeah, in any case, if you make any change to your application, you push it to your GitHub repository. I already have a workflow which builds a new image and pushes it to Docker Hub. So that whenever the Docker Hub is, whenever this integration happens, whenever the push happens, what this container app can do using this continuous deployment is automatically creates a new revision. So every time a push happens, there has to be a new revision which comes out. And by default, what happens is all the traffic which was coming to your application will be now directed to the new revision. So any change you make, if you make any changes to Dapper, if you make any change to scalability, or if you make a change to the image which you're using, all of that will trigger a new revision which gets created. So here you can see I have two different revisions. Just a sec. Yeah, two different revisions. So one of those revisions will have a service A written here, hello world from service A. The other doesn't have any message at all. So it's just a blank message. And here you can see I have divided traffic between them as 50% and 50%. So this is really powerful. I want you to understand that how simple this has become. Now, if you look back at the Kubernetes example we had, let's say you looked at the service deployment, right? We had a service A deployment, we had a service A service running there. Now, if I wanted to have two different versions of it, for example, usually we think of it as a blue-green deployment. So if I had a new version, if I had an older version, if I wanted my application traffic which is coming in to be equally split between these two applications, I would have to implement a lot of logic on myself. I would either use a third party, say HA proxy or HA proxy, these things kind of things, or I have to define some kind of a rule myself. Maybe I would define an ingress rule which specified, okay, the request comes in at this point, send this much to this much, send this much that. So all of that configurability would have to be done on my own. This load balancing between different parts would have to be managed by myself, right? I didn't have such an easy option of doing that. But here what happens is container apps basically abstracting on top of Kubernetes. So in the background, this is still running a Kubernetes service, but you're not allowed to access it. So we can't access the Kubernetes API directly, but at the backend, it is still using Kubernetes. But that is the idea behind container apps. So all of that is still the same. And say, for example, if you're configuring Dapper here, if you're configuring traffic management, all of this is handled automatically internally by Azure. That is the power behind using container apps. So if you want the same functionality of say Kubernetes cluster, but you don't want to manage all of those APIs yourself, you don't want to say set auto scaling or configure traffic management and all of that functionality, you can just easily go with container apps. It's built right on top of Kubernetes. It has Keda auto scaling built inside. It has serverless functionalities and also has this Dapper integration built right into it. So it's just Kubernetes, and then there's some more layers on top of it. So it just abstracts away all the different details about how a Kubernetes cluster is managed. So if I just change, say if I have 50-50% here, right? So let me just visit this URL for this application. So we'll see if there's a difference or not. So this is the URL here, and I try to access it. There's no message right now, right? So there's no message. I'll just refresh it. No message. Yeah, it should be 50-50 ideally, but I think it's just 100%. Yeah, there it is. Now it's saying service A. So my whatever request which is coming in, it is being transferred to two different instances of the same application, right? So this is still service A, but there are two revisions here, right? So we have two different revisions, and all of these revisions are 50-50%. Now I can have multiple revisions. I can try to slowly transition from an older version to a newer version so that there is no downtime. So all of that can be managed right from the portal without you having to know anything about traffic management at all. Correct. So this is something which is really powerful here. Again, this is the same thing. Sometimes services, sometimes it's blank. All right. So this is really cool. This thing is there. So I think we covered all about container apps. So here again, if you want to understand how important this is, you may think of we never configured any kind of VMs here. Right? We have no unused compute space or unused memory lying around. So we haven't provisioned anything on ourselves. We just defined that this is the image I want to run. This is the image of the container. This is my repository in the continuous deployment. Whenever I push to this repository, you should deploy a new revision. You should run it there. And where is this running? How much of the resources it's consuming? It's none of my concern. And it automatically scales depending on what event I specify. And so it is taking away all of that management, provisioning, scaling out of your hands and taking it with Azure. So all you have to worry about is your code and then your GitHub profile. That's the entire thing which you have to worry about. And even traffic management is made simple just by using this portal here. So that is the idea behind having a say container app. So it's really powerful, and it is the best option for deploying what you call microservices, because first of all, it has Dapper integration, which is really powerful. Because if you have say 50 services which are running on in your architecture, in that case, if you use some other way, for example, Azure Functions, first of all, it won't suit Azure Functions to run 50 different microservices. Say, for example, if you have at least one instance running at all times, so that just ruled out. In case of container apps, what you'll do is you'll have all these applications running inside one single environment, and then you can integrate all of these together with Dapper. So you don't need to have a service mesh in this scenario. You can just communicate using Dapper between different services. You want different databases for every service, you can do that using Dapper as well. Really fast integration, right? So when this is all of that makes this really the best choice currently for building microservices without having to worry about any of that. So typically we used to build microservices on Kubernetes using Kubernetes service, but this just leverages all Kubernetes functionalities without you having to worry about any of the underlying functionalities. This is really powerful. Really, I think it's going to take off really in terms of development in case of small organizations. We don't have to worry about any of that. So this is why I feel it is the best option for building microservices. Now let's just get back to our say one note here. So yeah, we talked about, so let's just get back to this point. So we have covered all the compute options for serverless here. So we looked at serverless Kubernetes, we looked at serverless functions, we looked at serverless applications, and we also looked at the container apps. And we have some idea why, like what are different ways in which you can use these things. So functions is usually responsible for event-driven kind of workloads. You can think of app service for mostly web apps. So if you have a web app which you want to host on Azure and you want to scale it independently and things like that, the best option for that is app service. Because in that case, we're not communicating with hundreds of different services. We're not trying to establish competition and stuff. We just have one kind of a website running, and we have an entire backend on back of it. So app service is usually the best optimized for web application hosting. Container apps, as I mentioned, is best for microservices. If you have a lot of microservices, they want communication between each other. The best way to choose is container apps. Now let's get to the serverless workflow and integration part. So Remember for
You can also add Keda as part of it.
yeah, as part of the workflow integration.
No, as part of the serverless implementation uh, of a microservice using Keda as well. Like you can do an event-driven scaling
Mm-hmm.
with that.
Okay, okay.
Yep.
Yeah, correct. Event-driven scaling is yeah. So Keda is automatically built inside of container apps. So under the hood it uses Keda for the scaling part. The portal which you saw, it was powered by this technology. Now the thing is not complete yet. So we just looked at the application part. Now coming to the API management, right? So in the case of Kubernetes cluster, you saw that I had Kong running as a service inside of Kubernetes cluster, right? So it didn't have I managed what resources the application used, what like how it managed all of that. But in the case of if I'm trying to transition to an entirely serverless model, in that case I don't want to handle where my API gateway is running, what compute is it using. So in that case what I use is a serverless API management, which is called the Azure API management service. So let's just quickly go to the portal again. Here I'll look at the APIM. So it's really powerful service. It has first class integration with different what you call where is it? Yeah, there it is. Yeah. Yeah, so it is first class integration with all the different microservices, all the different Azure services here. So this is how it looks like. Now without any further problem, let's just go to the API part here. So this APIs is where you define what your backends are going to be, what are different APIs which are going to be configured, right? So you can see I have a service say API built in. So think of it in this way: this API gateway sits at the front end, and now all of these different APIs are part of your backend, correct? Now the task which you have is to define the first of all define the paths at which this will forward it. So if you looked at it carefully in the overview, you can see there's a URL here. So this is the gateway URL. So this is a single entry point for all our applications here. So all of our APIs are going to be exposed using this particular URL here, right? So now this is the base URL. Now at what endpoint do I need to send a request to send my what you call communication to what different service will be configured here. So if I want to add an API, you can see there's first integration with all different services. So I can create an API from any of these services. So if I click on container app here, I'll be able to browse different container apps which I have on my what you call Azure subscription. So here you can see all those different three container apps which you saw earlier are here. So I can select service B, I can select this particular service, and then I will specify at what suffix from my gateway URL should this basically I'm defining routes here, right? So at what endpoint will my request should be forwarded to this particular container app is what I'm specifying here. So I think it won't be able to access it now because service B is not allowing ingress. I had disabled the ingress on that one, but I do have say service C automatically added here for just for demo purposes. So let's just go back to the APIs here. And in this case, let's just see if I can try to access service A here. So in the case of service A, I have say all of these different kinds of operations I can perform on it. And right for testing, let's just go to test option here. So this will give me what URL I want to post my request to, and then I'll be able to access it. For example, I just click on get. Right, so this is how I'll test my get function. So here you can see this is the request URL, right? So this request URL is the gateway URL / service A. Right, so this is kind of a route which is defined. So whenever I make a get request to this route, my request will be forwarded to this particular application. So let me just copy this here, this request URL, and let me try to access the same application which we are accessing earlier using this gateway now. So this API gateway, if I click on it, this should forward my request. Okay, this says access denied due to missing subscription key. Okay, this is because by default, any communication which goes through the API gateways will have subscription enabled. So you need to pass the subscription key along with your request. So I'll just disable that for now. So as I told, we'll look at very shortly all the different functionalities that this API gateway provides. But for now, I just want to test if you can access the same service again. So again, we'll just hit this URL again. So this is the gateway URL / service A route. Let me click on it. Networks, yeah, there again, hello world from service A. So, and what we are doing essentially is we have a fully managed API gateway, we have fully managed application backend, and we defined one route from this gateway to this particular API. I didn't have to worry about any compute instance. So where is this API gateway running? I didn't have to specify that. How much resources consuming? I didn't have to specify that. I just have to specify one important detail, which is I want to be on the consumption plan. So when you're creating an API gateway, you get multiple options for consumptions for the plans. So you should use a consumption plan, which only charges you per calls made. So you don't have, say, a flat charge with it, right? So make sure you click on the consumption plan. In that case, it becomes truly serverless, right? So it doesn't cost you anything to keep it running anyways. So yeah, this is the part. Now I remove the subscription required part. I can also add authentication here. So similar to the one we saw in Kong. So in Kong, I had to implement using a separate plugin because that was a third-party integration. But here, when I'm using a managed service here, so it can just directly integrate with you. So if I click on over 2.0, first of all, I'll have to define this what you call a server here in this authentication part, but I'm not doing it in this part. I do have a video on it. I do have videos on Kong gateway as well and APM as well. So we're not going to cover it here, but I'm just going through what are different functionalities we can add here. And plus we can also add things like rate limiting and all of those stuff using policies. So this is where you add the inbound outbound policies. So basically it's entirely managed. You don't have to worry about any compute resources, and you can very easily add backends using first-class integration. So this add API part really helps you, connect with all different services. You have an app service, you can have a function app, you can have, say, a container app here as well. So that is the idea behind using an API gateway in this sort. And we can see it still works in pretty much the same way. So you can access the same application using this gateway. So yeah, I think I've covered the API gateway part as well. Now let's just go back to OneNote to see if we have missed upon something. Yeah, so we have covered this as well. So for truly serverless solution, we first optimized our compute. We first changed how our application is running. So from running in a Kubernetes cluster, we transitioned to using the container apps for our microservices. So this allowed us to not worry about any of the provisioning or scaling. Now for the API gateway, earlier we used to run it on a Kubernetes cluster on our own, and now we're running it just as a managed API management service. Correct. So this is how you transition from a traditional approach to an entirely serverless approach. And now if you want to know about databases, one way of doing it is using Dapper. Now Dapper in itself will provide first an integration with any kind of databases. So if you go check out Dapper's website, so you mostly see Dapper database plugins. If you search for that, you will see you have multiple different options there. So you have just a common interface, but you don't have to worry about what database you're using, right? So in that case, you'll just check out this docs. It's really really interesting project. You should definitely check these things out. So we won't be covering all of that here. We've done that before. So in the case of building blocks, you'll mostly find the kind of different parts here. So you can see you have state management, you have service to service invocation, you have pub sub functionalities, you have, say, secrets also you can manage here. So all of these things are provided automatically. So instead of state management, here you can have all kinds of different databases here. And this is, and using Dapper, you get different database per app which is calling it. For example, if I'm accessing the database using some particular application, then it will access only one instance of the database, which is not accessible from other applications. So it by default enables the database for service pattern here. So you don't have to worry about implementing that as well. So Dapper makes it really simple. So yeah, coming back to the OneNote part here. So we have covered the compute, we covered workloads, and we also covered databases. So that one way of doing it is through Dapper. Another way of doing it would be just create SQL database serverless. So this is just an instance of SQL databases where you can create a serverless database. We also be charged as you use it. I haven't used it myself yet, but I just looked at the documentation for it. But if you're looking for a SQL table and a serverless solution, you should check this one out. Right. So this is the idea behind it, and let's just review all of that. Right. So earlier, this was a traditional approach. We used to provision a VM, or we used to provision an AKS cluster, run all our applications there, or maybe use an app service for our applications, right? And now what we did is we removed the gateway and we used an API management service, which was serverless in itself. It's fully managed. You don't have to worry about any of that. And for applications, we use container apps, which in itself is again running on top of Kubernetes, and it's entirely manages all of that. You can also scale to 0 for having a truly serverless experience. And you can also optimize. You can also add other offerings. For example, Azure Functions you can use. For example, you don't have to implement the entire solution just by using one container apps, right? For example, if you have some kind of events inside of your application, you can also use Azure Functions for that part, right? So it's just a combination of different services. I hope there's clarity on why we used what we used, because there are a ton of options. There are multiple ways in which you can implement serverless. So that is why it's really important to understand that there's no hard boundary on things like that. You can always choose between different kinds of things. You can see what works best for you. So this is the end of our session today. This is all I had to share with you guys. Now let's just go back and see if we have any questions, and we'll be happy to answer all of those things.
Yeah, so there is one question, Jayesh. So can I use API gateway with the VMs? Now, if I have if I have an application which is running on a VM, microservice
Mhm.
app, and if the API is exposed, like the VM is exposing the
Yeah,
link,
yeah.
whether we can use the API gateway, I think yes.
Yeah, definitely we can do
But
that.
there is an option called webhook and other things which is there where you can select. So if you can just show that in the portal.
Yeah,
Uh,
yeah, I
good.
was trying to do that. Yeah, honestly. Okay. So this is in the add API section. So first of all, you had this primary integration with app service function app things. But if you scroll up, you see there are also ways in which you can define them on custom. So you can have if you have an open API standard, if your application is using open API, you can just define that here, or you can even create a manual
Yes.
kind of addition. So it doesn't only work with serverless; it can work with any kind of backend here. So there's also WebSocket, as you said. So there you can
Yeah.
also connect with that.
So there is one question. So are we concluding that if you have to build a microservice, serverless microservice, that means you have to go with container apps? Is that the best option? I mean, I let Jayesh, give his perspective, and then I will give my perspective for that question.
Yes, so as I said, there are multiple ways in which you can implement it. For me, I found the container apps to be the perfect choice because when I'm building a microservice, what I want is communication between different services because that is essential. Every time you have say multiple microservices, there is most definitely going to be a way to communicate between different services. Right? So you have dapper integration built right into it, which is one of my favorite features. And apart from that, I have scaling, I have revision management, continuous deployment. So for me, if you look at developing an application, I think containers would be the primary choice I would use. But say for example, if I have such kind of an architecture where most of my work is event driven, right? So I don't need to have an instance running at all times. So in that scenario, I would go with an entirely, say for example, functions based architecture. So it depends on what kind of use case you have. So with my personal experience, I used more kind of container apps things. But if you have a different usage, then you can feel free to use any kind of architecture. Is what I
Yeah,
think.
so that's true. So basically, it's all based on your how you want to build it, and it is also the business use case, business requirement. There could be something like you want to go ahead and use Kubernetes itself, right? Because you could have many number of microservices running, and maybe different services, not just the one application. It could be different applications as well. You want to use one Kubernetes cluster with different namespaces. So that is also possible. So there are various options. The thing is, from today's discussion, what we know is how many options we have to
Correct.
build with using a serverless. If you're building a microservice application, what are the options we have? So there are a couple of options, and one of the option was the container apps, which Jay showed as a demo, but there are a lot of other options as well. Yes.
Definitely. Yeah, as you said, if you want to access Kubernetes APIs, that the best option would be AKS. Because with containers, you don't have any option to manually change the properties or increase the node size on any of that. So it depends on the use case again.
Yes, sure, Venkat. We will definitely share this recording. This will take 48 hours from now, 48 working days, 48 hours working days, because tomorrow and day after tomorrow is holiday.
Yeah,
Don't
definitely.
ping me and ask where is the recording until Tuesday. Okay, so definitely we'll do that. Please go through the survey link. This is the survey link. Please make sure that you provide the survey for this session. And if you have any questions, please ask questions. And it was a really wonderful session here because we had microservice application. In fact, we understood what microservice is, and with that microservice application, what are the ways you can build through serverless is what we discussed here. So it was really amazing. By the way, Jayesh, amazing. Thanks for walking us through with all this demo. And any questions, we are still there. We can still
Yeah.
spend 5 more minutes. If you have any questions, please do share. While, we have these waiting for the questions, you can also take the survey link and provide the survey. There is event ID. You please provide with the event ID.
Yeah.
Any questions? Thank you very much.
Is that it? Okay, thank you, folks. I really had a great time enjoying the entire session, and I look forward to like hearing from you again. Like maybe we'll come back for another session, and feel free to send me a message again if you have any question apart from this. So
So there is one request, Jayesh, is that whether you can share the notes which you
okay,
have
yes,
somewhere, maybe on your LinkedIn or on maybe as a part of one of the LinkedIn post where you can post all these things so that Sohail or anyone else can pick
Mhm.
it up from there. So that will
Yeah,
also
that is a great idea. That's a great idea. I'll try to find a format in which I can take the OneNote pages and maybe build a PDF out of it, and then I'll post it on LinkedIn for everybody to see.
yeah.
Yeah, that's a great idea.
So thank you, Vivek, and thank you, Jayesh, for such an amazing session. And thank you, folks, for joining us today. Please feel free to do event check-in and share your feedback about today's session. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again and enjoy the rest of your day.
Thank you, Rashmina. Thank you, Vivek. See you
Thank you,
then.
Jayesh. Thank you,
Bye bye.
Rashmita. Bye.